Our work was focused on analysis of dynamic interplay between behaviors of players, in a famous MMORPG called A Chinese Ghost Story 2, that has been launched for 5 years in China. The game creates a virtual society in which millions of players interplay with each other by assuming various characters and enrolling themselves in one of 4 cliques, namely Barry, Mountain, Temple, and Goon, under a persistent gaming environment. Interactive and self-participatory are embedded in MMORPGs. Thus, millions of players have invested monetary, cognitive, and social resources in different MMORPGs. Understanding the patterns and dynamics of player behaviors is economically significant for game companies. It also allows social scientists to examine the interplay between players. However, there are 2 key challenges. The first one is how to detect correlations among behaviors in an enormous amount of complex data. The second one is how to understand the detected patterns. To address the challenges, we develop Explorer, a visual analysis system which enables analysts to interactively explore the dynamic interplay between player behaviors. FlowView depicts players' dynamic social interaction and purchase behaviors. Players are divided into 8 groups according to the cliques and sophistication. Clicking on the purchase nodes will pop up flows of each group. Double-clicking enlarges this view. Gray flows represent players' purchase behavior, and the width of flows encodes the average purchase value of the corresponding player group. Social interactions are visualized using colored streams that are stacked together. Blue, red, and green colors are used to encode direct communication, triadic closure, and social influence respectively. The width of each stream encodes the interaction effect, whereas the dot density is proportional to the value of the corresponding interaction variable. Users can click on the streams to see the corresponding influential bar chart at the selected time frame. It presents the distribution of a certain social interaction effect from 8 player groups. If users are confused with the visual encoding, just click on the name of the view and the explanation will be shown. Users can observe how players' purchase and social interaction behaviors evolve separately, or how do they co-evolve over time. If users switch to product mode, player susceptibility to influence on different categories of products will be displayed. It helps users observe the similarities and differences among the communication influence exerted on the product purchases. Users can zoom into the correlation view by clicking on a certain time frame. Purple dashed rectangles and arrows are used as visual cues for drilling down process. This view allows intergroup and intragroup correlation analyses of player behaviors. A radial visualization summarizes the intragroup characteristics at the selected time frame. This view combines a donut chart and 8 pie charts. Arc length encodes the number of people in each group, whereas the pie charts show the distribution of the player's purchase level. Comparison of attributes can be made by clicking on the sectors of pie charts, which represent different levels. Users are able to discover distribution of other in-game attributes. Colored curves appear when the pie charts are hovered, which represent the social interaction between a selected group and other groups. It uses the same color scheme as influential power streams, and users can switch to another interaction variable on the control panel. Intergroup comparisons on communication behaviors can be made via the left plus button. Clicking on the name of this view will prompt the explanation of the radial visualization. A pixel bar chart and parallel coordinates are used to enable users analyze the players within a specific group. Selecting a sector of the donut chart will show a pixel bar chart that visualizes a large amount of attribute data of the corresponding player group. The three parallel coordinates visualize the three types of social interaction variables. Users can select an area from the pixel bar chart and compare with other players in this group with the right plus. A table view and a graph visualization will be updated for providing details of the selected players. The table illustrates attribute values of selected players. A force-directed graph draws the ego network of a selected player. We started by looking at the evolution of behaviors of Group M. The purchase flow showed a downtrend. The dot density of blue and red streams decreases, while that of green stream increases over time. In other words, the direct communication becomes less frequent, and the average shared partners between players of the Group M and others become less. On the contrary, the difference of the sophistication scores between players of the Group M and other players becomes larger, which means the sophistication scores become lower. Game analysts should promote players' communication in the game other than purchase. We then analyzed behaviors across different player groups. 4 purchase flows of B, M, T, and G between July 29 and October 7, 2013 are displayed. Flows B and M demonstrate more fluctuations than flows T and G. We speculated that there is a positive correlation between the changing rate of purchases and susceptibility to influence. We also observed that click T had relatively higher communication frequency, with more shared friends, and higher purchases. We suggest that the game operator should dig deep into the game setting for this click to better understand the reasons behind the phenomena. We switch the default group mode to product mode, and select C3 and C4. We found that the susceptibility to influence of C4 fluctuates frequently, since the width of C4 influential power stream keeps changing. The finding suggests that it would be more consistently cost-effective for the game operator to influence the purchases of C3 through promoting players' communication. This is because this category's susceptibility to influence is more stable and thus is more reliable.